So our lecture today, following the kinetics, is about the mode of cultivation, or what you normally say, okay, it's a mode of fermentation. And in cultivation of the microbial microorganism, there were three main cultivation modes. Okay, there are some other variation as well, but the main one, they were all based on this main mode of fermentation. So what we are going to see today are what batch cultivation is, understanding the batch cultivation, fed batch cultivation, and continuous cultivation. Okay. The first thing first, when we are talking about fermentation, we are talking about cultivating things in the fermenter. Okay, so when you are cultivating things in the fermenter, of course, mass balance is important concept in this case. Okay, so the three different modes of fermentation will have different mass balance. So if you look at the mass balance around the fermenter, like you see in the pictures, what could happen is that you could feed something in, okay, into the fermenter. And there could be something that get generated. So like the cell will grow, okay, and product is formed, or something could get consumed, like the substrate could get consumed in the fermenter. And also there could be something out from the fermenter as well. So the mass balance around the fermenter, okay, if you see the fermenter, the system, the mass balance around the fermenter follow this equation. This is the general equation for the mass balance. If we are following a substance A, okay, A could be biomass, A could be product, A could be the cells, okay. The changes of A in this system would equal to A that goes in, okay, minus A that comes out, plus A that is generated and A that is consumed. So it is the mass balance for A. You see that A in and A generated is positive. So that means that it goes into the system and it being put in and it's being increased in the system, versus the A out and A consumed, which is something that has been taken out of the system or disappear in the system. And if you change this equation, this expression into mathematical equations, the changes in A is of course dA dt. Okay. Hold on. Okay. I'm not sure why doesn't it said it will end in 10 minutes. Just to make sure that if it ends in 10 minutes, can you get the officer to re-enter the link again? Okay. Okay. Just let's continue. If the changes in A is dA dt, and you know that this dA dt is the reaction, is the A kinetics, okay, is the rate of change of A, which is something that we talked about before, okay, and A in, okay, of course A in, it has to be the flow in, okay, so it is the flow rate of A that goes in. to the fermenter. Okay, A out is the rate of A that is out of the fermenter. Okay. And the A generated, okay, is changes of A that happens in the fermenter, and the A consumed is the rate of A that has been consumed in the fermenter. You see a different subscript here. Okay. So this is the general mass balance of the fermenter. Okay, and this equation is the basis for all the main cultivation modes. Okay. Now, let's have a look at the first mode of cultivation, a batch cultivation. Okay, batch cultivation is it's a closed system, of course. It doesn't have anything going in or coming out of the fermenter. So you put everything in the fermenter at the beginning, okay, and you let everything go until the end of fermentation, and then you harvest your product or your cell or whatever at the end of the cultivation once. And with the batch cultivation, since it's closed system, nothing goes in, nothing comes out, there is no change in volumes. Okay. And the mass balance for the batch cultivation can be done for all the kinetics that we are interested in. So it can be done for a substrate, it can be done for biomass, and it can be done on the product as well. So in batch cultivation, of course, when you put substrate in, the cell grow, the substrate is used. So for the mass balance equation, you don't have anything in. So that's why your flow rate of substrate in is 0. You have nothing coming out during the batch cultivation. So the flow out is 0. And you know that substrate doesn't get generated. So the generation of substrate, the rate of generation of substrate is 0, but the substrate is consumed. So that's why your dsdt equal to minus ds that is consumed over dt. Okay, so that is based on a substrate. Okay, things could get complicated if you have byproduct that can be a substrate for the cells as well. So that's something that could happen also. Okay, for the biomass and the product in batch cultivation, it is something that is increased because you start fermentation, the cell grow, so that's change in biomass, and the product is being produced, so that is change in product as well, and both of the change are the positive change. You don't have flow in, so that's why it's 0. You don't have any flow out for the batch cultivation, so it's 0. And the biomass and the product get generated. So this is how you see the batch cultivation. Okay. And in the future, if you read a lot of research paper, you will probably come across the word repeated batch. Repeated batch is a popular variation of the batch cultivation. So it's sort of like doing the batch repeatedly. Normally, when you start the batch fermentation, okay, you have the substrate in, and you start the fermentation by putting an inoculum into the fermenter, into the media. Okay, probably like 5% inoculum, 10% inoculum. It depends. Okay, it depends on your your design of the experiment. And after the fermentation is done in the batch, you harvest it. if you do one batch fermentation, you harvested everything, okay? But in repeated batch, you are harvesting most of the stuff in the fermenter, and you left with a little bit of thing, like you left with 5% of the content of the fermenter, 10% of the content of the fermenter, and harvesting the rest. And then you add the fresh media in. So whatever is left at the bottom of your fermenter is acting as an inoculum. So each time you harvest, so you ended one batch, but you are not harvesting all of them. You have something left as an inoculum for the next batch that you put your fresh media in. Okay, so that is called repeated batch. Okay, the good thing about repeated batch is that you don't have to spend time preparing inoculum, because in normal batch fermentation, you have to have sometimes preparing an inoculum. And if you are doing like in a big fermenter, you probably have to do the inoculum seedings for like a few times, and it takes time. It could take like 1 day or 2 days just preparing the inoculum, an inoculum alone. But with repeated batch, a good thing is that you don't have to do that every time you want to do the batch. Okay, so because at the end, whatever is left is acting as an inoculum by itself. Okay, so that's why people are interested in repeated batch. But there is also a downside for repeated batch as well, because the cells that is get left in the fermenter, okay, is left with the product as well. And if it produces something that is toxic to the cells, so you start having like a toxic product, a little bit of it every time. And the cell itself are not really fresh. Because if you go back and have a look at the growth curve, you see that you will harvest at the steady when the growth start to be stable. So that means that you have both like old cell and new cell at the same time. So the cell is not always fresh. So when we are doing something with repeated batch, we have to monitor each time that we do the batch and see if the performance of the fermentation decrease. Okay, so it can't go on forever. That's what I'm saying.